Good afternoon, everyone, and welcome to the Smithsonian's National Air and Space Museum. We are in the Moving Beyond Earth exhibition gallery, which is our gallery about spaceflight during the Space Shuttle era and on the International Space Station. And today we are really fortunate to have with us an astronaut, a U.S. astronaut who has flown on both the Space Shuttle and a Soyuz spacecraft from Russia and has spent almost 6 months on the International Space Station. His name is Dr. Tom Marshburn. He is an MD, a medical doctor. His specialty was emergency medicine, and he's been a flight surgeon for NASA for a number of years before he became an astronaut in 2004. He had one mission to the space station on the Space Shuttle, where he did 3 spacewalks. And then he had this 6-month stay on the International Space Station where he had the opportunity to do one more spacewalk. In addition to all of that, he has a lot of other interests. He is a backpacker, a scuba diver, a mountain climber, and in addition, he has a birthday coming up in August, early August. So join me in welcoming Dr. Tom Marshburn.
Hey, thanks everybody. Thanks for your patience and thanks for coming out all the way from Australia and around the country. This museum has always been like the center of the universe to me. I used to work out in Maryland about 30 years ago and would come here and spend about 8 hours a day for almost every day that I could actually down in the museum, so it's a real privilege to be here. Thanks for letting me come out. One thing that Valerie didn't mention, I came back from the space station just 2 months ago. So this is what a person looks like 2 months after floating around for 5 months in space. So I've got my Earth legs back now. I don't think I'm going to throw up on anybody. I'm not going to pass out. So don't worry. I think I'm all up for this, standing on the stage now. But it's good to talk to you. Just so you know, the International Space Station is one of our country's national laboratories. It is a research laboratory. And it looks like that. It's a lot bigger. With the solar arrays, it is the size of a football field. It is huge. It is flying around the Earth in orbit about 250 miles up right now. It's been doing that since December of the year 2000. We have had an American on board the space station for 13 years. We rotate out. It's been a different person. And actually, it's been either a Russian or both a Russian and an American always on there. But now we've had many of our international partners, 16 nations around the world, who have been a part of flying on the International Space Station and doing research. So that's what it looks like. It's huge. It's about the living quarters is about the size of a 5-bedroom house. So it's actually, for a spaceship, it's the roomiest thing that's ever been built before. One thing a lot of people don't know is to fly in space, you have to be traveling really fast. Otherwise, the gravity of the Earth takes over and will pull you down and you'll fall into the atmosphere and burn up because you're going so fast. You have to go 17,500 miles an hour to stay in orbit at that altitude. So that's 5 miles a second that we're traveling. We're always doing that on the space station. That's how fast it goes by. So with that introduction, why don't we go ahead and start the video. There's always 6 people on board the space station. That's me on the far right. The 3 guys on the right are my Soyuz crew. 3 people in a Soyuz launch and go to the space station. And we switch out 3 at a time. We had 3 new crew members come up while we were up there. So there's usually 6 people, sometimes just 3. It takes 2.5 years to train to get ready to fly on the space station. You have to learn the technical part, you have to learn how to run the space station, and you have to learn how to speak Russian. Fly jets, to fly a spacecraft, to do spacewalks. This is one of the biggest swimming pools in the world. This is where we do our spacewalk training. The module, or a mock-up of the space station, is submerged underwater, and we get to know every inch of that thing so that we can get outside if we have to and do an emergency spacewalk and fix something. We're just at a laptop-based simulator there. This is just days before launch. We're in quarantine. They keep us away from everybody. just prior to that time, this is the Kremlin Wall. As you may know, since we don't have the space shuttle now, the only access to the space station is with the Soyuz, Russian-built Soyuz spaceship. So we're a part of their traditions as we get ready to go. I was laying flowers at Gagarin's grave, Yuri Gagarin, the first human to fly in space. This Chris Hadfield is a Canadian that I flew with. Many of you have probably heard of him. He's become quite famous through YouTube and Twitter. And Roman Romanenko in the center is the Russian Soyuz commander. We just finished our final exam. And on the day of launch, you wake up, come out, and a Russian Orthodox priest slaps you in the face with cold holy water, just to get us all woken up. It's one of the very rich and I think quite beautiful Russian traditions that are now part of our space flight as long as we launch on the Soyuz. They put us on a bus and we're gonna go get suited up. We're just hours away from getting into the rocket, and then we're gonna lie there in the rocket for a few hours waiting for the launch. We're at the end of almost 3 years of training now. We're in our suits. We have to do a pressure check. No one can come up to us except for the technicians. That was our families that were on the other side of a glass wall there. I'm getting a pressure check right now, but this view kind of gives you an idea of how small the spaceship is. We have to sit with our knees crunched up to our chest, and 3 of us kind of are arrayed there. It's almost like sitting in the front seat of a little VW. But we were the first that got to wear these really cool looking Michelin Man suits. It was negative 40 degrees out there, so they designed these suits to keep us warm just when we were walking out there. The last human hands that we touch before we leave the Earth is the chief of Roscosmos, and then we climb up on a ladder and get in the rocket. Rockets will take us from a dead stop in the middle of Kazakhstan to 17,500 miles an hour in 8.5 minutes. To do that, enormous amount of fuel, obviously. You feel a lot of pressure on your chest, 4 Gs on your chest. That's 4 times the weight of your body on your chest. It gets to where, after several minutes, it gets hard to breathe. You have to take your breath in sips. The whole time we're watching the panels, watching what's going on, and doing a lot of thumbs up and sky fives as we're going up. Although your arm's really heavy, it's hard to sky five at that point. But the feeling of speed is incredible. I flew on the shuttle before that, and I would say the Soyuz rocket is actually a little bit smoother. It's not quite as bendable in plastic, so you don't get quite as much rattling. But the staging, which you're about to see here, staging is when you drop off your empty tanks and continue the rockets going. You now have a lighter spacecraft. There's the spacecraft. There's the staging. We had 4 boosters on the side that come off. So this is the beginning of second stage. And when that happens, it's a huge kick in the back, almost like getting rear-ended in a car accident in the back. Throws you forward, and then you're slammed back again as the next rocket takes over to continue to propel you into space. We spend 2.5 days in space. This is during the launch. That's me on the right side. You saw Rahman hit me saying, "Hey, Tom, the camera's on, wave." That's that big white thing that was sitting behind us. That was a parachute. We're going to need that when we get back home, and you'll see that. Our buddies on the space station who have been waiting for us took this video as we come in to dock to the space station. Those jet firings you see look nice and quiet, but they're actually big booms, big cannon booms that are nudging us into the docking position. And there we are docked to the International Space Station. Open the hatch and come floating through, and it's party time for about 2 minutes. Because right away you have a press conference. And so that's coming up. That's all of us back in the service module. We're answering questions from leaders of the Russian Space Agency and the US Space Agency. And we're just hoping we don't get sick or anything, because we've just arrived in space a couple of days ago. And appetite wasn't quite normal yet, but we all were feeling pretty good. The 3 gentlemen in the back have been up there for 2 months by the time we arrived, waiting for our arrival. But right away, once you get on the space station, you go to work. You're working off a timeline that is marked out in 5-minute blocks. They have complete control of your day there. So we do a lot of maintenance. That was a scientific rack I had rotated out and working behind it. That's a big telescope I'm getting ready to install. And our main job up there is to do experiments. So we'll spend 6.5 hours a day just working experiments, working in this laboratory with investigators all around the world talking to us so we can get their research done. Several times during the flight, we get resupplies. A resupply means a rocket has to put another spaceship up there that has no people in it, but just has our food, our clothes, underwear, and mostly more experiments. That is the SpaceX Dragon. It's a private industry in the US that launched that to us. We grabbed it with our robotic arm and stuck it on the space station so we could access things in there. So the experiments continue. I'm a medical doctor. One of the things I was interested in is using ultrasound in space. I'm sure you've heard of ultrasound. What's unique about doing it in space is you can use water instead of ultrasound gel. So that's just regular old water on my hand, stuck to my hand because we're in zero gravity. That's my hand, actually, on the ultrasound image. But in zero gravity, you can do these kind of wonderful things with an ultrasound machine because you don't have to worry about the effects of gravity. Worked with did a lot of robotic operations. Some of the clinical investigations I did involved something as simple as getting medicine into a syringe. It's kind of hard to figure out how to get the bubbles out. So we tried some swinging techniques. You may have seen the nurse, or you may have done it where you flick the syringe to get the bubbles to, and it doesn't work in space. It just makes a big fine mist of bubbles. So we tried to figure out ways to get the air out of it so you don't want to inject that into someone. We did arrive on the space station just before Christmas. So NASA sent up those little stockings for us that had some chocolates in it that was very nice. This face you probably recognize, Chris Hadfield, the first Canadian commander in space. We had just some fun times up there when we get fruit and vegetables on one of the new cargo vehicles, sends that up to us, and our first chance to eat something fresh for a while. We have to pack the Dragon itself. Once we've emptied it out, it's empty, and now we're going to put stuff in there. Dragon is the only capability we have for actually returning things to the Earth. Those boxes weigh about maybe 200, 300 pounds, and you can see how easy it is once it's moving to move it around. That box there, that's a tool chest. We're kind of in my garage, and there's our toolbox, and that maybe weighs about 100 pounds, but it's just easy to spin it around in zero gravity. Our Russian colleagues were wonderful to work with. The official language is English up there, but if we're in the Russian part of the space station, we'll speak Russian, and when they're on our side, they'll speak English. It's actually a lot of fun, and as you can imagine, a lot of chances for humor as we mess up each other's languages. Now, halfway through the mission, Kevin Ford, test pilot, U.S. astronaut, and his two Russian colleagues went back to the Earth, leaving just Chris Hadfield, myself, and Roman left on the space station. We're still packing the Dragon right now. This is a minus 80-degree freezer. We have frozen experimental results that we're packing in that we're going to put into the Dragon to return to Earth for analysis on the ground. You can put laptops on the wall, on the ceiling, anywhere around you as you're working on experiments. On this particular experiment, this is called the nanocube. These are experiments that are flown up by universities and even high school students, a cheap way into space. I'm packing these up to put them in the Dragon to return to Earth. There are, we were working on about 130.
Tom and the tape are moving that way.
The station is leaving me behind. See you later.
All that was a reboost. We were trying to capture the motion of the station when it actually fires its rockets to get us in a higher orbit, and it was very, very faint. You could barely tell. We're doing about 130 experiments. Our new crew is coming up to help us. Right now, these three gentlemen that have been floating through the hatch, they are on the space station right now. If you've been watching the news, you may have heard about a spacewalk that happened a couple of days ago. We had to cut it short. On the right-hand side is Chris Cassidy. He was out there doing that spacewalk. They're still up there living and working and will be until the fall. But it's great to have your new crewmates on board. It really adds a lot of life to the station to get the newbies up there. We spend a lot of time showing them around how to be efficient, where things are located, things the ground couldn't have trained them on before they got there. Now here's Chris helping me out with a robotics experiment. I've got motion sensors on my hands, I've got 3D goggles on my head, and I'm going to be controlling an anthropomorphic robot, the Robonaut, which you may have heard of before. And my motions, my head motions, and what I do with my hands, the robot's going to do itself. The purpose of this is maybe someday we can send that thing outside to do a spacewalk, and I just do the motions, or the astronaut does the motions on the inside. So there's the space station. We have a great model up here too. And I want to show you this because a lot of people don't have an idea of, number one, how big it is. It is absolutely enormous. Football field in size. Where we live, you kind of see an upside down T shape. That is where the people are. And those cylinders, they're stuck together kind of like Tinker Toys. The long bar in the middle, the truss, is actually not populated. There are not people living in that. That's just to support those enormous solar arrays. The space station is essentially a power station on orbit. And you're going to see some video here now of us flying around on the habitable part, but we're going to show some video of a spacewalk we had to do, an emergency spacewalk we had to do at one end. One of the joys of doing a long-duration space flight, instead of the shorter 2-week-long shuttle flight, is that you get really good at living in zero gravity. When we first get there, we couldn't have done this. We'd be hitting our head on the hatches, we'd be banging into the walls. You feel like a baby deer on ice sort of when you first start. But you can pick up some speed, so you got to be careful. But it's fun. It's not only fun doing the work, but it's fun going to work. And if you have to go get a tool, it's fun going to go get it. The only problem is the time pressure. We are under a lot of time pressure to get a lot done in a short amount of time. So I'm going to show you how you make a meal in space. This is our kitchen. All it is a water dispenser. It can give us ambient water or cold or hot water. We don't have a cold water dispenser. I'm making scrambled eggs, and you got to admit that looks really good. So about half of our food is dehydrated like that. So we got to inject water into it, squeeze it up. The other half of the food is in foil pouches, so all you have to do is heat it up. So you might think the kitchen is there on the wall, and I'm actually now preparing a meal for my crewmates. But actually, the kitchen is on the ceiling. But you can turn any wall or floor into a ceiling or whatever you want to do in space. It doesn't matter. It's all the same. So my crew is in the dining room, and I just throw the meals over to them once I'm done rehydrating them. You have to, it takes a little practice. You can mess it up. That was not intentional. That was an actual mistake. And you can even eat nuts out of a can if you spin around to keep the nuts in the can. So one day, 4 days before we returned to Earth, Pavel Vinogradov, one of our Russian crewmates, looked out the window and saw this. You see the white things coming off? That is what ammonia looks like when it hits the vacuum of space and freezes into little particles. That is a bad thing. You don't want to see anything moving around outside your space station. We realized those ammonia crystals. The ground did analysis of that video you saw and some other photos we took, found out we had a leak on the far end of the space station, way out on this model here, way out on the end of the truss segment. If you lose your coolant, then you're going to lose power because you got to have coolant in order to keep the power flowing. So we were at risk of losing a lot of the power to the space station. So in about 30 hours, the ground developed the procedures and the timeline for us to get in our spacesuits and go out and try to fix the leak. And this was just 4 days before landing, right at the first couple of weeks of May. Putting on a spacesuit is like putting on a spaceship. You got your comm, your water, your coolant, your propulsion, everything you need to live out in the vacuum of space. That is Chris Cassidy and myself. We went out to that area. Those boxes are our different pump assemblies. Turns out one of those was leaking, so we took it out and put a new one in, and it ended up fixing the leak. But we're floating around the vacuum of space. We have tethers to keep us attached to the station. If we come off and are not tethered, you're not going to live because there's no space shuttle to come and get you. So we have to stay tethered to the space station. Have to be very careful about that. That's a thermal cover. As we're coming back in, we had a 5.5-hour spacewalk, and Chris is about to close that up. And then we're back inside, and we're very relieved to find out that we were able to fix the leak. Usually NASA thinks it'll take, it was planning on 9 days to get ready for a spacewalk, and they were able to pull it off in 30 hours. One of the best things about living in space, of course, though, when you have the time, is looking out the window. That's the cupola. It's the best view ever, except for inside your spacesuit. It's the best view of the Earth that's ever flown in space before. That's the Caribbean Sea there. This is a fast stop-motion view of flying over the Earth and solar arrays spinning as they keep facing the sun so they can always get the sunshine on the solar arrays to generate power. That's the European Alps right there. We're going to see the Aurora Borealis coming up. We can have some nice night cameras there, stop action film, and that's what the northern lights look like when you're looking down at the Earth as the sun is rising. Nighttime is a magical time. That is when you can see the the biggest imprint of human habitation on Earth is at night, to see all the cities across Europe. But the time comes when we have to come home. Those are the suits we wore coming up. So now we're floating around helping each other get our spacesuits back on again. So we're flying through the Russian segment of the space station, climbing back into our Soyuz spaceship. Like I mentioned, it's a really tiny place. It feels weird to live for 5 months on a big old space station and find yourself back in this tiny little Soyuz again. Ramon's down in the center. I'm off to his right. Chris Hadfield is off to his left. Just enough room to get in there with the hatch. We barely have enough room to close that hatch up. Landing in the Soyuz is completely different from landing in the shuttle and has got to be one of the most spectacular things that you get to do in space. You come flying through the atmosphere about Mach 20, 3,000 degrees on the outside. Your heat shield protects you, then your parachute opens, and you land like this in the Kazakhstan desert. It's a thump down. It's more like a smack down, really. It's what it feels like. One astronaut said it feels like 2 explosions followed by a car crash, and they were right. We knew it was going to be tough when in training they said, okay, when you come up to the landing, make sure you're not talking because you don't want to bite your tongue off when you hit. So we kept our teeth clenched. But it's a very effective, it's pretty brutal, but it's a very effective way of getting people home safely. And there we are at the end of our flight. And the last little segment here of the video is me coming off the helicopter that picked us up from the landing site, brought us to the airport. And that's just about an hour after being in space for 5 months. I was able to walk with some help over to the bus there. So that's the end of the video presentation. But I have to say, you can be extremely proud of your country and all the countries around the world that have built this, which is considered the most complicated engineering endeavor ever attempted by human beings. From around the country using metric system and the imperial system of measurements, sticking this thing together in space when these parts had never met each other before, because we built it over time, put it all together in space, and we are just now realizing the capability of doing the research up there. We've been doing research all along, but now the amount that we can do just keeps getting to be more and more and more. And the capability keeps on increasing. So it's an extremely exciting endeavor, and what I'd like to do right now is just to answer questions. I know I couldn't talk about things, a lot of things that probably people are interested in knowing about. I'm willing to answer anything about living in space and what it's like to be up there. So please, if you got a question, you can come to the mic or raise your hand, whatever you'd like to do. Yes, ma'am. With the free time, the most popular thing in space is to look out the window. And we have a whole suite of cameras as well up there right by the window, so we just get up there and we just start taking pictures right away. I had some books. We had a guitar. You might have seen Chris Hadfield had some popular videos that he playing the guitar. I'm a classical guitarist, so I did a little bit of that. You can email home, you can call home, and usually that's what we do. But most often we're looking out the window. I heard a question over here before we get to the mic. Is it hard being an astronaut? And you know, it is. It is. But one thing is true of all the astronauts I've ever known is that they love to work. We love doing our work. We especially love this job. So even though it's hard, it's a lot of fun, and we just love keeping on doing it.
Hi, I'm George from Bloomington, Indiana. And my question is, how important is it to learn math in order to do this?
How important is it to learn math? Well, I tell you what, you know, especially in this spacecraft, we are doing basic math all the time, particularly in emergencies. You always have a computer. Spacecraft nowadays have computers to get you up safely. It's very complicated getting into space, very hard. We can just barely do it. And we have computers that can just barely get us there. But computers break. You probably had a laptop that's died on you before. So we train. And it has happened before when your computer can't do the math for you, getting to space and coming home. So we have charts, graphs, and we have to do the math in order to survive, to get us up into space and back home safely. Now, having said that, to be an astronaut, there are a lot of engineers, a lot of mathematicians, people that have shown that they can do technical work. So math, physics, all of the STEM field, science, technology, engineering, and math, those are all absolutely essential today for getting into space and being successful up there.
Thank you.
Thanks.
Hi, my name is Greg Adams from Clovis, California.
Hey.
Because you're with each other for so long, it's important to keep morale up. So do you guys like pull pranks on each other? I know America, Russia, so.
So do we pull pranks on each other because
Yeah.
just to keep morale up?
Or what do you do to keep morale up?
Yeah, to keep the morale. Actually, what we do, and yeah, pranks. The one prank that is consistent, and it's so common that it's like all right, but it's a lot of fun. It always causes laughter. Is we have a communication system with the ground, but we don't have continual satellite coverage to enable that communication. So you're talking to the ground. You could say Houston Station on 2 for robotics or something, and then they come back on. They talk to you. Well, sometimes if you don't look at the schedule and don't realize there's not a satellite there to communicate it, we'll get on there and say Houston Station on 4 for robotics. And another crewmate realizes the ground can't hear you, so they'll get back on another loop on the intercom and go ahead on 4. Go ahead on 4. Wait, somebody just turned the sound up. And just in a funny voice, and you realize, oh gosh, I just made a fool out of myself because the ground can't hear me. So that is a very common prank we play on each other. To keep the morale up, the work does it. Successful work does that, but so does the holidays and occasional meals. We'll fly over and share food that we brought up from other countries. And it's a lot of fun. Thanks.
Yeah. My name is Bill. I'm from Austin, Texas. My question is about landing. I assume you've landed in the ocean, and also you said in the desert. So I just wanted you to talk a little bit about the difference between those two
Yeah,
operations.
the difference in the landing. Actually, I haven't landed in the ocean. We haven't done that since we used the Apollo spacecraft, because the space shuttle would come down and glide and land on a landing strip.
Right.
And we landed in the desert here. The Russians have always landed on the ground. They had one where they ended up in a lake accidentally, but so they have thump downs. And so what I did was a very controlled glide on the space shuttle, which is a bit like an airliner, except for the fact you're pointing at the ground like that as you're coming down, so it really gets your heart rate up. But the Soyuz is completely different, and it is spectacular. It's violent. That means it's a lot of fun. When you come down, you're tumbling actually. You come down into the atmosphere. You can see the flames of the heat shield going by you. I could see chunks of my heat shield coming off and just whipping by the window, and then the window was blackened over. And then when you keep on coming down, your parachute opens up, and that is a huge hayucca where you're spinning and whipping at the end, and we were just hooting and hollering because that part's a lot of fun. But then you get ready for that smacking onto the ground that I described to you, and you clench your teeth and bring your elbows in and get hunkered down really tight, and then a big smack down there. So they were completely different, and actually I highly recommend the Soyuz landing. It was wonderful.
So that's safer than the other.
Yeah, it's brutal, but it is safe and it's reliable. There's no doubt about it. Yep.
Thanks very much.
Thanks.
My name's Mike. I'm from Maryland. I guess 4 years ago you were starting your first flight on the shuttle, and I was wondering if you could take some time to compare a flight on the shuttle for a week or two as opposed to 5 months on the ISS.
The differences in preparation?
And similarities.
And similarities. The similarities are that what you mentally go through to get ready for a space flight. And approaching it's a completely different approach. One thing I always tell students in school is it's not as important what you learn as it is to know how to learn, and how to learn very quickly. I had to retrain how to learn from what I knew as a medical doctor to getting ready to fly in space. The panels and turning a procedure into action as fast as possible, that's the same for all spacecraft. The big differences are the Russians are really good at their simulations. They will dump smoke in there with you. They will turn off all the lights on you. They'll overheat you. They do have some great simulations in the little tiny Soyuz as you're getting ready for flight. And in the U.S. side, the computer graphics, the technical part of the simulation is really wonderful. They complement each other very well. I wouldn't say one's better than the other, but quite a bit different actually. It's wonderful. Thanks.
I'm Isaac from Kentucky, and I was wondering, how does a real space flight compare to the simulation in a pool?
Oh, for the training for spacewalks. How does the actual spaceflight compare to being in the pool? That was the best spaceflight training, and most astronauts agree, that we've ever had, because you have the actual station mock-up. You're floating in water. Now that means you're still sitting in your suit, and you can kind of rest a little bit and rest in your suit, because your suit is actually floating and you're kind of inside of it. If you turn upside down in the pool, you can feel it. All the blood goes to your head and your shoulders hurt because now you're hanging upside down inside your suit. So in zero gravity, you don't feel any of that. You are floating in the middle of your suit just perfectly. The other big difference is the temperature extremes outside in space is about plus 300 degrees Fahrenheit to negative 200 degrees from sun to shadow. And you can feel that temperature difference. Obviously, the suit's protecting you from that, so you don't die, you don't roast or freeze to death at the same time. But you can feel the heat leaving on the night side. You can feel the heat accumulating on the day side. You start to break into a sweat. And the other difference is the incredible view. There's no way to simulate that at all. And it's actually quite difficult to go to work, to quit looking out past the space station at the Earth below you or space around you, and to continue concentrating on the work. And that's probably the biggest difference.
Thank you.
Yeah, thanks.
My name is Ronnie, and I'm from Massachusetts, and I have a question of how does gravity work?
How does gravity work? That is a great question. You might answer that question someday. We're not quite sure, unless there are physicists out there that can correct me, whether we have gravity waves or gravity particles, but we do know where there's mass, there's gravity. And so you get enough mass, a planet-sized mass, say enough like the size of the Earth, then you can feel the gravity that we feel right now. There's actually gravity between all the little tiny parts of the space station. The force is so tiny we don't feel it. But what's interesting is you can feel the differences in gravity from the different altitudes of just inside the space station, and you can put something far down, something that's closer to the Earth, that's maybe 30 feet away from something that's further from Earth, and over time, if you can cancel out the wind, the ventilation of the air, you can see those things slowly separate from each other. It's really fascinating. Well, that's a good question. Maybe you'll answer it for sure, and come back and tell us all.
Hi, I'm Christopher from California, and it's always been my passion to become an astronaut. And so I'd like to know how you got started and how you were inspired to become an astronaut.
Well, you got the first step taken care of, and that's being passionate about it. People that fly in space these days typically have loved spaceflight most of their lives, are very passionate about it. One thing is for sure, even if they hadn't thought about being an astronaut, they became passionate about something. Astronauts are usually good at something. And to be good at something, you usually have to fall madly in love with it. So what I usually tell people that want to be astronauts is to find out exactly what astronaut you want to be like, decide today, like right now, that you're going to be that person, and start acting like an astronaut, which is learning as best you can, doing as well as you can in school, taking care of yourself, and you're going to find something, if you haven't already, some passion that you have. And today we need science, technology, engineering, math. In the future, we'll be including journalists and artists and poets and musicians up there as flying in space and living in space. But falling in love and having that passion will be the biggest driver and the most important step in becoming an astronaut. That and persistence, just keep trying. I didn't join the astronaut corps. I didn't get in until my third attempt, my third application. So you got to keep trying. Good luck.
Thank you.
My name is Ella, and I come from California, and I was wondering if you missed anything back at home.
Did I miss anything back at home while I was in space?
Yes.
You bet I did. You miss Earth. Earth is a good place. I loved visiting space. I'd like to go back again, but Earth is always the best place to come home to. I miss my family a lot because I didn't get to see. I have a daughter that's 10 years old. I didn't get to see her grow and change every day. I miss my wife a lot. And then far third from that was I missed a good cup of coffee and a shower and a sandwich. The sandwich is great because it has everything you like. It's got the crusty and the nice warm bread and the whatever, chicken salami and fresh crunchy vegetables. None of those things you can have in space, at least not right now. And so I miss those things too. And that was a great question. Thanks.
Thank you.
Sure. Sir, you had a question there earlier. The most difficult thing to overcome while you're in space, I would have to say it's actually on a day-to-day basis, it's getting better at it. When you're living in a laboratory, you are finishing up the experiments that people have been working on for a decade, or maybe even more than that. And so doing the homework at the last second, getting ready to start the day when everybody's looking over your shoulder, and you're literally on stage for a lot of people doing a technical experiment and trying very hard to be as exact and as perfect as you can be. So learning how to do that each day was important. Did we ever get perfect, and did we perform the experiments perfectly? Well, thank goodness we have the ground to catch us on things. We made a pact that we're going to try to have one perfect day in space where we'd make no mistakes at all. And by the end of the mission, none of us had done it, and none of us had even gotten past about 10 a.m. before we'd made some kind of mistake at some point. Spaceflight's really complicated, and despite all the training, we're humans, we're going to make some mistakes, so we need to all work together to make it happen. Yes, sir.
Good afternoon. My name is Jeff, and I'm from East Grand Rapids, Michigan. And I was wondering if you could tell us a little bit about your physical training prior to and during your time on the station. Thank you.
Physical training, yeah. There is actually a limited a number of restrictions for physical training, how fast you have to run, pull-ups, that kind of thing. There is some. And so you have to meet some gates of physical training. But astronauts are typically occasional athletes, if not actually semi-pro or professional athletes. A number of them are professional as well, or were. So NASA just relies on you to stay in shape. And if the weight, body mass index starts to get a little bit out of the norm, people let you know. Sure. We have trainers, we have flight surgeons, they let you know, and they have the facility, so it's up to you to get in there and make sure you stay in shape. And it is important because in an emergency, yeah, you might be running outside of a spacecraft in a heavy spacesuit. Spacewalks are very, very physically intensive, very tiring. But even dealing with the changes in gravity and the acceleration, I found that people perform, and it's certainly true for me, you perform better, you get sick less if you're in shape. So that's one of the prime motivations.
Okay, great. Yeah. Thank you.
Thanks.
Hi, my name is Patrick, and I'm from Bethesda, Maryland. And I was wondering if you were ever concerned that space junk might ever hit the space station.
That's a great question. Would space junk ever hit the space station? It's a huge concern for NASA. That space station is huge. And as you know, there's orbital debris out there. So what they have is they work with the Department of Defense, and they have a radar that's looking at, it can detect everything in space that's bigger than a golf ball. So that's maybe about 10 to 20,000 objects in orbit. They're tracking all of them. And if one of them even looks like it might hit the space station, then they let us know. And they're either going to move the space station out of the way, or they'll tell us to get inside of our Soyuz spaceship to get ready to undock in case whatever it is hits the space station. They're looking all the time. That's a big danger of flying in Earth orbit right now. We did not have to do any of that. We were very fortunate that we didn't have to move the space station to get away from anything. But it's a great question. We also train really hard. The 3 big emergencies in space: fire, decompression, and a toxic atmosphere. Something leaks into the air. We can't run to a window and stick our head out to get a fresh breath of air. But obviously, if you get a hole in the spaceship, you lose all your air. That's a problem too. So that's the third big emergency that we train for. So we're ready if it happens. Yeah, we worry about it quite a bit.
Okay, thank you.
Thanks.
Hi, I'm Brendan Krebs. I come from Seattle, Washington State.
Uh-huh.
And I was wondering, how long does it take to get from Earth to the moon?
To get from Earth to the moon, we could all go back and look it up. I think it was taking the Apollo astronauts several days, 3 days to get from the Earth to the moon. That included an Earth orbit, and we fire another rocket. Check out your systems first, and then fire a rocket to head that way. So it takes a few days to get out there. It's 200,000 miles, I believe, to get there. So our chemical rockets, that's about the best we can do right now.
Okay.
I'm Kelly, and I'm from Washington, and I was wondering, what does it feel like the moment that you get into space?
What does it feel like the moment you get into space? It's wonderful. You know, you've probably heard about space motion sickness and people getting sick when they get into space. And yeah, that happens to a certain degree. But what you feel like is, it's amazing because it's in comparison to what you've just been experiencing, which is your launch. And these hugely powerful engines that are just throwing you, pushing you up, you're crushing in your chest because from the acceleration, the loud vibration and the thunder of the rocket, and then suddenly it's all gone. And when that rocket engine stops, you're in orbit and you're free falling around the Earth, and you go from huge pressure in your chest to zero gravity. So what it feels like is I felt like if you ever gone on a roller coaster over the top of a hill or driven a car real fast over a hill, I wouldn't recommend it. Still, you feel your stomach kind of go up, you feel blood go into your head. That's exactly what you feel. The only difference is it doesn't go away. The blood stays up in your head and your stomach stays up there kind of high. When I was on the space shuttle, the first time I got into space, I unstrapped my seat. First of all, I knew I was in space because my pencil was on a lanyard and it started tumbling in front of me. And then I unstrapped to get a bag that was under my chair. So I leaned over to get the bag, and I didn't think to stop that motion. So my rear ends came up over my head. So I found myself completely upside down, continuing to tumble, and my rear end about to smack into the wall as I'm just trying to get this bag under my seat. So you learned pretty fast that it's completely different up there, and it takes about a day and a half just to be able to function and do useful stuff up there.
Thank you.
Thanks.
Hi, I'm Casey, and I'm from California, and I was wondering about how long does it take to recover from being in space?
Well, I'm 2 months right now, so this is where I am, and actually I feel great. My stamina is not quite what it used to be pre-flight. My bones are not quite as strong as they used to be, but they're slowly recovering. That can take 6 months to a year. My eyesight changed. The shape of my eye changed a little bit. We're just finding out that that can happen to astronauts. That may never get better. But what happens as soon as you land is that you feel really wobbly. The Earth is just rocking and rolling under you when you first get back because your inner ear hasn't adapted yet. Your blood is falling out of your head or wants to fall out of your head back in the gravity field. It hasn't had to deal with pushing blood up into your head for 5 months. So your body takes care of that in just a couple of days. And you get better at walking. The flight surgeon released me to drive after about 3 weeks, which includes whipping my head around and that sort of thing. So it's a slow progression of steadily getting better. We go through a period of pretty bad muscle soreness because your muscles haven't had to hold your body up or even hold your head up for very long. So those muscles get sore, and then that gets better. And then you can start exercising harder and harder to get back to where you were pre-flight. So I'd say right now I could tell you it's going to take me about 2 months to get to feeling completely normal again.
Thank you.
Thanks.
Hi again. My name is Troy, and I'm visiting from Santiago, Chile. I'd like to ask you about the oxygen in the station. Well, it obviously came from Earth, or...
How's the what?
The oxygen in the station. Where did it come from, and is it limited? Do you...
Mm-hmm. So the air, the oxygen that we breathe,
exactly.
Yeah, to stay alive up there. We have tanks of compressed oxygen on the outside of the station. Getting compressed oxygen to the station, though, is pretty tough. The shuttle brought those tanks up there. We don't want to have to refly those and have them plug them into the system. So they're for spacewalks and for reserve. So the air that's in the space station now, it is atmospheric pressure, so it's just like what we're sitting here in right now. It's about 72 degrees. It's nitrogen and oxygen, just like we have down here. Our bodies do metabolize the oxygen, but just a little bit. A lot of the oxygen that we use actually comes out in the urine from our bodies. It comes back in the water we exhale and the urine. We reclaim all of that, and it becomes tomorrow's drinking water, and we even have a little bit of leftover to put oxygen back into the atmosphere. So we can almost have a complete closed loop. Besides that, the Russians in their Progress vehicle, the Dragon spacecraft can do it as well, can send up just what look like big scuba tanks of air. And so as the station pressure drops a little bit, either from very tiny leaks that nobody can, usually it's not leaks, it's pretty tightly sealed. Usually it's the oxygen that we've metabolized in our bodies. They just open up those tanks and let the air flow back in again. And that's the main source of oxygen to keep us up there.
is Francisco, and I live in Mesquite, Texas. So, which food is your favorite one in space?
What's my favorite food? That's hard to say. One of the reasons is because I found out I like different kinds of food. When you have to eat the same thing over and over again, you found out, boy, anything would be better than this. Although it's great food. The food is wonderful up there. We have a rotating cycle about every 16 days. The menu starts all over again. And so out of all of that, the food lab that makes our food does a great job. I think my favorite, it was called Fiesta Chicken. And it was the shredded chicken with some hot sauce. Our noses get kind of plugged up with the fluid shifts, and so you like a little spicier sauce up there on the ground. And that was a little bit spicy. And putting that on a tortilla, so you get the tortilla out, and you can just take the spicy chicken, which is kind of sticky, and just kind of throw it and slap it on their tortilla. And you can even throw that tortilla to the guy you just made it for over there. So tortillas are great. You can throw them like Frisbees. There's one of the favorite things we have up there. But fold that up, and it's wonderful. I think that's my favorite thing.
Frank, also from Mesquite, Texas.
Hey.
When you were tethered to go outside the space station, was there a certain amount of oxygen that y'all had, as far as time frame, or
how much when we're on the spacewalk? How much oxygen do we have? You're right. We don't have an umbilical. We're not getting a station supply. It's all in our backpack. So we have about 8 hours of oxygen in there for us to use. But we also have at the bottom of the backpack these tiny little tanks that are full of 30 minutes of emergency oxygen. So we get a hole in our suit and it starts to leak out. If we go too long, have a huge problem like we can't open the hatch. When that opens up, we have 30 minutes and that's it. So about 8.5, 9 hours, depending on how hard you're working and metabolizing that oxygen. That's how much we have.
Okay, thank you.
Yeah, thank you.
Just a fellow physician here wondering how, if there's anything clinically relevant as far as zero-G goes with different disease processes you may be interested in or have seen. I'm Doug from Colorado.
Yeah, the things you think of first are the cardiovascular system. I think they've ruled out that there's any problems with the heart. That is arrhythmias, heart attacks, cardiovascular disease being accelerated, being in space. We don't have that, but the vessels get atrophied. The blood vessels, the vessels in your legs and your arms, they get kind of weak. They get kind of atrophied because don't have to squeeze down to get that blood up to your head anymore. Osteoporosis, bone loss. The longer you stay in space, if you don't exercise, the more like a jellyfish you're going to become. It's easier floating in space than it is even just sitting in the chair or lying in bed even. So that's a big deal. In terms of getting an illness or an injury, it's pretty hard on the immune system, although we haven't seen that. Fortunately, people haven't been getting like viral illnesses, so we don't know there's a longer progression of that at all. But you're in a stressful environment, and how stress can affect the human body, and I suspect that it would affect the time course of an illness. What we deal with mostly in space is injury, and so trauma to the hands, especially the eyes. Space is really hard on your eyes, because imagine all the dirt on the floor here. If it's suddenly zero gravity, all that dirt's floating in the air. So you got to keep it really, really clean, but you can still be flying through the space station and go whack, something hits you in the eye, and just oh. But the good, easy thing is you can get a drink bag and just squirt it on your eye, and it makes a big dome of water right over your eye. You just open your eye and close it and blink, and you can usually wash it out. But we've got ways of cleaning out your eyes if that doesn't work. And so there's a whole slew of first aid and usually minor trauma that happens up there.
Hi, I'm Kyla, and I'm from Jackson, Mississippi. And I was wondering if it was hard to digest any fluids in outer space, since research shows that it was hard to take showers, and since the water would be floating in the atmosphere.
That's a great question. Something I never knew about, I'd never heard, is this sort of answers your question, is you can't burp in space. And that's for the same reason you're saying. You eat the food, and I think your body has to adapt to this. You eat the food, you drink your fluids, inevitably we swallow some air, and so there's not like the food and the water are down here and the air is up here. It all mixes together into a foam, and that's why it's really hard to burp. I did burp once, but I didn't feel very good. The difference between a burp and a barf is really close in space, and so you don't want to do it. But you have air in your system, and you can then imagine what happens at the other end. We tested out all the explosive gases in space and found out that you can't burp in space, but your body adapts.
Thank you.
Hi, my name is Alicia, and I wanted to be an astronaut when I was 10, and then I figured that my math sucks, so here I am doing politics. So my question is kind of, sort of policy-oriented. I grew up in Pakistan, and I'm still a Pakistani citizen, which is why I can never do anything with NASA at all. So I know a lot of very, very bright people back home who would love to collaborate, and one of the reasons why we are really bad at progressing is because there are very limited opportunities, if any opportunities at all. So would you know, or do you think that in future or near future, there'll be some sort of collaboration with people from countries where there are very, very limited resources, and NASA can maybe help out, and maybe we can do something together?
Yeah, so in terms of international partnerships of flying in space, right now spaceflight is very difficult and expensive for everybody, including the U.S. It always is. It's an incredibly complicated endeavor. So we've gone so far as including 16 countries in the International Space Station. Each one of those countries has to contribute a certain amount, either hardware or people or funds, to participate in this adventure. I'm hoping that with the commercial crew, with private companies getting vehicles up there, that's going to open the open space to so many more people, not just people who can buy a ticket, but even to countries who can purchase a seat for their own astronaut from that country to go up. And I feel like that's the future for it. Now, I do know that NASA is interested in continuing international cooperation when we get beyond low Earth orbit, Moon, Mars, asteroid, all of those things. While it remains incredibly expensive right now, that's going to limit it, but with the future of commercialization of space, it's going to open up the windows to everybody.
Sounds good, thank you.
Thanks. Okay. Yes, sir.
Hi, I'm Jerry. I'm from Mexico City, and I was wondering, how do you shower?
How do we shower? So imagine what it'd be like to shower in zero gravity. So if you had a bathtub and a shower head, you turn on the water, and the water might hit you, but it would go all over the place because there's no gravity to make it go on you and down into the tub. So you'd have to take a shower inside of like a big, I don't know, a big Ziploc bag or something. And then when the water came in, you still have to grab the water and put it on you. And after you're done, you'd have to clean all that water up. Not to mention that in about the first minute of the shower, you'd run out because that's about all the water you have immediately available to take a shower with. So we don't take showers. We tried to. I think they tried in Skylab, and it was just too messy and too complicated. I think they tried on the Mir space station, an old Russian space station, as well. What we do is we wipe ourselves down with wet wipes. You can either use drinking water on a towel, or we have like those big, just wet wipes for your hands, a big version of that we put some water in it and just rub it all down on our bodies. We do that every couple of days or once a week, whether we need it or not, and just clean ourselves off. And that seems to work really well. And we have a special shampoo that you don't need any rinse with to clean our hair. It feels great. We feel like we're clean. I never once thought that my crewmate smelled, and they never thought I smelled. So it seems to be working. So that's what we do. We just do wipe downs.
Thanks.
Thanks.
My name is Miguel. I'm from California. Since you're a medical doctor, what types of medicine do you practice?
What type of medicine do I practice? I'm an emergency doctor. One of the reasons why I went into that was because I wanted to be able to take care of everything, a little bit of everything. So an emergency doctor is not an expert in any one thing except maybe getting a bunch of patients through an ER, but is an expert in a lot of different things. And that's kind of what an astronaut is like, and that's why I wanted to go into emergency medicine. All these complicated systems on a space station, we aren't the expert on any one of them, but we do know a little bit about all of them. And that's why I went into emergency medicine. Okay. I think that we're about out of time. I'm going to have a little bit of time with you outside the door there, but I understand they need to close this down for another event coming up. Thank you all very much. Enjoyed answering your questions. Appreciate it.